All right, so today on section 12.6, we're going to bring in more of the conceptual method of multiplication of decimals by using a model. We're still going to do the procedure alongside of it. That way we can kind of double down on both understandings as we progress. But doesn't this remind you of fraction multiplication, where one fraction is modeled going up and down and one is going across part of a part? And
Yes.
the overlapping section represents the answer. So we're going to handle it in the same way that we did fraction multiplication. We will draw X's on top of the overlap spot and then decide on the value of that group. And that'll do it. Okay, so we're going to just do a couple here together. We're only working on 205 today because we spent so much time sort of with remediation on the previous sections here. So let's read and try to understand the example here for the next minute, okay? Read it, look at the model, and try to make some connections. Go ahead. So, I mean, one extra piece that I'm going to recommend is that we put X's on the overlapping spots, because that acknowledges for Mrs. Moore, I know where the answer exists. I know where the product is. The product is the place that contains both regions of shading, right? And how many of those little tiny boxes have X's in them? 24 of them, right? 24 out of what does the total group contain? 24 hundredths. So when I put 24 in standard form, I have to make sure that 24 lands in the hundredths position. So we're actually going to start at the bottom of our page. I want you to go all the way down to number 7. And maybe we can use this model up here to just justify our thinking here. It says, explain the relationship among the sides of the grid, the size of the small squares, the area of the small squares, the area of the grid. So let me just talk to you a little bit here, and we'll use the space to write out a little bit of our understanding. What would I can't quite, here, let me see if that works. What would this represent right here? You don't have to draw this on your paper, but what would this represent? This entire square. Esther, what would it represent?
0.6 times 0.8.
Just what would the square represent? That's all I'm wondering.
The answer.
This entire square is just worth one whole, right? Right now it's empty. It's 1. It's equal to 1 whole. And so on your paper here by number 7, this is what I want you to do. I want you to write 1 whole square with 100 parts equals 1 whole. And then 1 tiny square. What's 1 tiny square valued at? What's the value of one of those pieces? Michael, what's the value of that?
1/10.
Close, but it's 1 out of how many parts? Not 10 parts. It's 1 out of
100.
100 parts. So that's how we write it as a fraction. How do we write this as a decimal? How do we write 1/100th as a decimal? Go ahead, Landon.
0.1.
That would be 1/10. How do I write 100th?
0.01.
That's right. So on our description here, one tiny square is equal to 1/100th, or in decimal form, 0.01. And then for this last line, I want to write 1 row of 10 squares, 10 tiny squares. What would 1 row of 10 squares be valued at? So how many tiny squares are in 1 row? 10 out of 100.
10.
Right? So 10 out of 100 is the same as what decimal? 10 hundredths, right? There's a cleaner way to write that is just 1/10. 10 hundredths is the same as 1/10, right? If we just snip off that extra valueless 0 on the back, we can see that it's equal to 10 tiny squares is equal to 1/10, or as a decimal, 1/10. All right, so this part at the bottom here, this kind of key will help us make some understanding on the top part, okay? I'm going to erase these so that I can use that space for my other learning. And let's go back up to the top. Go back up to the top. All right. So we are going to use the blue section to model one number and the yellow section to model the next number. And then the green, the overlap, will represent the product or the answer here. So I could go and count each one of these tiny little blue squares all by itself. 1, 2, 3, 4, 5, 6, 7, but that would take a long time. I do know that one column is worth 1/10. So could I just say 1/10, 2/10, 3/10 like that and go faster? How many tenths are colored in this blue shading here? How many tenths is that?
6.
1, 2, 3, 4, 5, 6, 7 tenths. So how would you write 7 tenths? You would write 0.7. How many tenths are colored with the yellow? 2 tenths, right? Let's put X's on the overlap. 1, 2, 3, 4 hundredths, 5 hundredths, 6 hundredths, 7, 8, 9, 10, 12, 13, 14 out of 100 are double crossed, right? So I'm going to write my multiplication sentence now. 7 tenths times 2 tenths will equal, what is the final product? What will 7 tenths times 2 tenths equal? 14 hundredths. How do I write 14 hundredths? I have to make sure the 14 lands in the hundredths position, right? Did I do it? All right, good. Let me check it procedurally off to the side. 7 tenths times 2 tenths. Remember, ignore the decimals until you're done with the multiplying. What is 7 times 2? 14,
14.
right? How many decimal zones are there in this number? 2, right?
2.
So both of these have to be behind a decimal point, right? So we're going to push that decimal point back in front of this. Now we have 2 decimal zones. You can put a 0 there for just structure. Okay, tell me out loud. Number 2, how many tenths are colored here?
3.
Okay, so I could say 3 tenths, or I could say 30 hundredths. Either way, it's the same value. How many of the yellow ones are colored? That's a lot of them, isn't it? How many of the yellow ones are colored? I'm counting 8 tenths. Yeah, or 80 hundredths. Either way, you can see 80 out of 100 are colored, or 8 out of 10 rows are colored. Here's my overlap. 1, 2, 300, 4, 5, 600, 7, 8, 900, 10, 11, 1200, 13, 14, 15, 17, 18, 19, 20, 21, 22, 23, 24. 24 what? 24.
100.
And this is how we write it, 24 hundredths. Check it procedurally where you have some space. 3 times 8, 24. How many decimal zones? 2.
2.
So does it check out?
Yes.
Yes, it does. Okay, scoot down to number 4. I want to practice a shading one before you handle the rest on your own. Number 4. Oh my goodness. What's happening in there? The Spanish class today is a little wild. They're using fly swatters. I don't know what's happening in there. So, okay, now we're going to do the opposite. We're going to model the problem and prove the solution. So we could do this procedurally real quick. We know 6 times 8 is 48, and we know there's 2 decimal zones in the problem. So that would change it to be, we know this is the answer to expect. So we know 48 out of the 100 pieces, 48 hundredths, will be double shaded. Let's prove it. So let's shade with your lighter color, 6 tenths, 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, going one direction. And then I'm going to use another color going the other direction to model 8 hundredths or 8 tenths. Okay, and it doesn't matter which row you start in, as long as you color the whole row. 1, 2, I could do that better. 3, 4, 5, 6, 7. This is harder than it looks on the computer. All right, can you see the space that has double shading, right? Is it starting to show through? So put your little X's on all the pieces that are double shaded. And this looks like it will take me all day. But there will be, how many pieces do I know there will be when I put all my X's? How many pieces will be double crossed, boys and girls?
That's a lot of crosses. I don't know if I can keep up.
But we know 48 of them will be double shaded, right? Are we all right with this material? You feeling good? Can you finish those last couple problems for me? So you do number
Yes.
3, 5, and 6. Take a picture, submit it. All right, and then Paige and I are gonna work. So what I'm gonna do is stop my recording here unless there's any more questions, and then I'll upload it as soon as Paige and I are done, okay? All right, kiddos.